Hello everyone. Up to now, we have seen about the images formed by the convex lenses of the chapter, that is lenses. By the concave lenses, we can obtain the images obtained by the concave lenses using the following rules. When the incident ray is parallel to the principal axis, the refracted ray, when extended backwards, passes through the focus. This is the one rule which we have studied, and when the incident ray passes through the focus, the refracted ray is parallel to the principal axis. These were the two rules which we are using for the formation of the image, as after the that refraction occurrence through the lenses and the image is formed. So we have studied about the formation of the image as in the convex lenses. Yes. So next we are studying as shown in the figure 7.9, object PQ is placed between F1 and 2F1 in the front of the concave lens. Incident ray PA starting from the point P and going parallel to the principal axis goes along AD after the refraction. If AD is extended backwards, it appears to come from the F1. Incident ray PO starting from the P and passing through O goes along the same direction after refraction. PO intersects the extended ray AF1 at the P1, that is P1 is the image of the P. Means as we are studying about the for image formation by the concave lenses, so we are taking here the diverging lens, that is and we are applying the same rules as we have studied about the rules while applying for the ray diagram as for the convex lenses. So same rules we are applying here for the concave lenses, and we have seen here that when the object PQ is placed at in between the two F1 and F1, so the image formation is occurring so inside the lens. So that is the P dash is the image of the P. Means here we can see here P dash and Q dash is the image which is formed here. So as the point Q is on the principal axis, its image is formed along the axis at that point Q dash directly below the P dash. Thus P dash Q dash is the image of the PQ. The image formed by a concave lens is always virtual, erect and smaller than the object. So again this is one of the important point related with the concave lens, as the image formation of by the concave lens is always virtual, erect and smaller than the object. But अगर हम बात करेंगे अगर कॉन्वेक्स लेंस के इमेज फॉर्मेशन की, सो कॉन्वेक्स लेंस के इमेज फॉर्मेशन में इमेज स्मॉलर हो सकती है, पॉइंट इमेज हो सकती है, लार्जर हो सकती है, वेरी लार्ज हो सकती है. इट कैन बी द रियल, इन्वर्टेड, वर्चुअल और द इरेक्ट डिपेंडिंग ऑन द position of the object which is placed. But in the case of the concave lenses, that is the diverging lens, so image formation will be a virtual, erect and smaller than the object. This is the difference between the image formation by the convex lens and the concave lens. So there are only the two ray diagrams formed in the concave lenses as mentioned in this table. So when the object is at placed at the infinity position of the image formed is on the first focus f1, size of the image, point image, nature of the image, virtual and direct. See, one thing we can keep in mind that the image will be formed by the concave lenses will always be virtual and the erect. So the nature of the image will be constant, as the position of the image will be formed depending on the position of the object which is placed. So if the object is placed at the infinity, image position will be formed at the focus f1. Size of the image will be the point image. And second is that anywhere between the optical center O and the infinity when the object is placed, so between optical center and the focus f1, there will be the formation of the position of the image. So size of the image will be small and nature of the image will be virtual and erect. So these are only the two ray diagrams of which detailing is given in this table. So next is the can you recall section. What is the Cartesian sign convention used for the spherical mirrors? और जो spherical mirrors का जो sign convention था वो हमने क्लास 9th में इसके बारे में हमने देखा था, that the sign convention which we have used for the plotting of the ray diagrams and to do the further calculations regarding with that. So यहाँ पर साइन कन्वेंशन क्या है? So as we can see here, height above the principal axis we are taking as the positive, below the principal axis it is negative. Then the direction of the incident ray will be right side, towards right, and direction towards the right of the origin will be taken as the positive, and towards the left it will taken as the negative. Direction of the incident ray, refracted ray and all we are taking from the origin distance right positive, and from the distance left towards the that is the negative. So this is the sign convention which we are considering here, and the distance that will be the f1 and f2 and 2f1 f2 focal length, focal distance, as we have studied about it in the previous part. So next is the lens formula. The formula showing the relation between the distance of the object u, the distance of the image v, and the focal length f is called as the lens formula. It is given as 1 upon v minus 1 upon u is equals to 1 upon f. Again, ये जो formula है, this formula is important as many of the numericals may ask in the exam related with this lens formula. And the numericals are easy. Only we have to substitute the values according to the distance of the lens which we are considering here. So only we have to keep in mind the importances of the plus and minus, that is the negative distance sign and all. So the lens formula, that is 1 upon v minus 1 upon u is equals to 1 upon n. The lens formula is same for any spherical lens and any distance of the object from the lens. It is however necessary to use the sign convention properly, as it is mentioned in this box that we have to carefully use the sign convention principle while using the lens formula. So according to the sign convention, the optical center O is taken to be the origin. Principal axis is the x-axis of the frame of the reference. The sign convention is as follows. First, the object is always placed on the left of the lens. मतलब object जो भी placed किया जाएगा that will be always on the left hand side of the lens. मतलब अगर lens यहाँ पर होंगी तो according to the lens, so the object will be placed always on the left side of the lens. All distances parallel to the principal axis are measured from the optical center, और जो भी distance होंगे principal axis के parallel, that all will be measured with the optical center as a respective. So second is the distance measured towards the right of the optical center O are taken to be the positive, while those measured to the left are taken to be the negative. मतलब जो भी distance हम optical center के right में लेंगे, that all distances will be considered positive, और जो भी distances जो optical center के left में होंगे, that all will be considered as the negative. Third point is distances perpendicular to the principal axis and above are taken to be the positive, और जो भी distances जो principal axis है उसके अगर upward direction में होंगे, so we are going to consider all that such distances as to be the positive, और जो भी distances below towards the perpendicular of the principal axis, that will all consider to be the negative. और एक जो इम्पोर्टेंट है दैट इज द फोकल लेंथ ऑफ द कॉन्वेक्स लेंस की अगर फोकल लेंथ होगी तो वो पॉजिटिव होगी, एंड द कॉन्केव लेंस फोकल लेंथ विल बी कंसिडर्ड एज द नेगेटिव. So these are the sum of the points which we have to keep in mind while doing the calculation or the using of the lens formula, that is 1 upon v minus 1 upon u is equals to 1 upon f. So this we have to keep in mind while doing any of the numerical solving, or doing the drawing the sign convention or the image diagram for that. Next is that of the magnification. So the magnification due to a lens is the height of the object.